Hello viewers, in today's session we are going to discuss the concept of image of a point with respect to a given line. So here we are given this problem where we have to find the image of the point 1 comma 2 comma minus 1 with respect to this line x minus 3 over 1 is equal to y plus 1 over 2 is equal to z minus 1 over minus 3, and also we have to find the equation of the line joining the given point and its image, right? So let us start. So let us call this line as L. So we have x minus 3 over 1 is equal to y plus 1 over 2 is equal to z minus 1 over minus 3. And here we have this line L, and suppose this point is point A and the coordinates are 1 comma 2 comma minus 1, right? So let us consider the image of this point A with respect to this line L as B, right? And suppose the coordinates of the point B are alpha, beta, and gamma, right? So let us join A and B. And here it is important to note that when we find out the image of this point A as B, then this line L, it acts as a mirror, right? And here this line AB is perpendicular to this line L, and let us call the intersection of this line AB and this line L as M, right? Okay, so here AM or AB is perpendicular to this line L, and the direction ratios of this line L are given as 1 comma 2 comma minus 3, right? Okay, so now we'll make use of the concept of a general point lying on a line. So here at this point M, it lies on this line AB and this line L, right? So here we'll introduce a scalar, say R, and R is a real number, right? So for some particular value of R, we can get the coordinates of this point M, right? So let us form the equations. X minus 3 over 1 is equal to R, y plus 1 over 2 is equal to R, and z minus 1 over minus 3 is equal to R. So let us find out the values of x, y, and z in terms of R, right? So we have x is equal to 1 times R, that is R plus 3, y is equal to 2R minus 1, and z is equal to minus 3R plus 1, right? So the coordinates of this point M can now be written as R plus 3, 2R minus 1, and minus 3R plus 1 for some particular value of R. And now our aim is to find out the value of this scalar or this real number R by the concept of perpendicularity of two lines, right? So here AB is perpendicular to this line L. So now let us find out the direction ratios of AM, right? So direction ratios of AM can be obtained by subtracting these two coordinates, because if we take A as say x1, y1, z1, and the coordinates of M may be taken as x2, y2, and z2, right? Then x1 is 1, y1 is 2, and z1 is minus 1. Similarly, x2 is r plus 3, y2 is 2r minus 1, and z2 is minus 3r plus 1. So the direction ratios of the line AB or AM can be obtained by subtracting the coordinates, right? So we can now have x1 minus x2, and then we have y1 minus y2 and z1 minus z2. So we have now 1 minus r minus 3, then we have 2 minus 2r, and then we have plus 1, and then we have minus 1 plus 3r. This becomes positive, and here we have minus 1. So we have here minus r minus 2, and then we have here a minus 2r plus 3, and this is 3r minus 2. So the direction ratios of AM are given by minus r minus 2, minus 2r plus 3, and 3r minus 2. And the direction ratios of the line L are given by 1, 2, and minus 3, right? And here AB is perpendicular to L. So we know that if two vectors or two lines have the direction ratios A1, B1, and C1, and A2, B2, and C2, and if the two vectors or the two lines are perpendicular, then the condition for perpendicularity is A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So here we can take the direction ratios A1, B1, C1 as these direction ratios, and A2, B2, C2 as these direction ratios. So applying this condition, because AB is perpendicular to L, we have now minus R minus 2 times 1, then we have minus 2R plus 3 times 2, and then we have 3r minus 2 times minus 3 is equal to 0. So now this is a linear equation in R. So let us solve it. So we have minus r minus 2, then we have minus 4r plus 6, and here we have minus 9r plus 6, and minus 4, minus 9, and minus 1. So we have minus 14r, and here we have 6 plus 6, 12. 12 minus 2 is 10, right? So minus 14r is equal to minus 10. So r is minus 10 over minus 14. So this is 5 over 7, right? So the value of r is now equal to 5 over 7. So now using this value of r, we can easily find out the coordinates of this point M, which is the foot of the perpendicular, right? So we have the coordinates of M as r plus 3. So r is 5 over 7 plus 3, and then we have 2r minus 1. So we have 2 times 5 over 7 minus 1, and then we have minus 3r plus 1. So this is 3 times 5 over 7 plus 1. So now we have here 5 plus 21 over 7. This is 10. 2 times 5 is 10. Then we have minus 7 over 7. Then we have minus 15 plus 7 over 7, right? Okay. So now we can write here 26 over 7, and this is 3 over 7, and this is minus 8 over 7. So the coordinates of the foot of the perpendicular, that is M is the foot of the perpendicular, that is AM. So the coordinates of the points point M are given by 26 by 7, comma 3 by 7, comma minus 8 by 7. So now using the coordinates of this point A and point M, we can now easily find out the coordinates of the image of this point A, which is point B, right? And here we have already said that this line L, it acts as a mirror. So this point M is the midpoint of this that is line AB, right? So M is the midpoint of AB. So from midpoint formula, we can write the coordinates of this point M as x1 plus x2 over 2, and then y1 plus y2 over 2, and z1 plus z2 over 2, where a can be taken as x1 y1 z1, that is 1 2 and minus 1, and the coordinates of point B are x2 y2 z2, right? So the coordinates of the point M are x1 plus x2 over 2, y1 plus y2 over 2, and z1 plus z2 over 2. Now the coordinates of M are also given by 26 by 7, 3 by 7, and minus 8 over 7. So here we can now write 26 over 7, then 3 by 7, and minus 8 over 7, right? And x1 is 1, and x2 is alpha, right? So we have 1 plus alpha over 2, y1 is 2, y2 is beta, and here we have 2, z1 is minus 1, and z2 is gamma, and here we have 2, right? So now comparing these two coordinates, we can now write three equations. So 1 plus alpha over 2 is equal to 26 over 7, and then 2 plus beta over 2 is equal to 3 over 7, and then minus 1 plus gamma over 2 is equal to minus 8 over 7. So now solving these three equations, we can now first we'll take this equation. So we have 7 plus 7 alpha is equal to 52. So cross multiplying here, and then 7 alpha is 52 minus 7, that is 45. So alpha is 45 over 7, right? Okay. Now here we have 7 times 2 is 14, then 7 beta, and 2 times 3 is 6. So 7 beta is 6 minus 14, that is minus 8. So beta is minus 8 over 7. And from here we have minus 7 plus 7 times gamma, that is equal to minus 16. 2 times minus 8 is minus 16. So 7 gamma is minus 16 plus 7, that is minus 9, right? So the value of gamma is equal to minus 9 over 7. So now the coordinates of this point B, which is the image of this point A, are given by 45 over 7. Then we have minus 8 over 7, and then we have minus 9 over 7, right? So this is how we can find out the coordinates of the image of a point which is A with respect to a given line L. So now we have to find out the equation of the line joining the given point, which is point A, and its image, which is point B. So we need to find out the equation of the line that is AB. So here we have the point A, and here we have the point B. So a is 1 comma 2 comma minus 1, and here we have the point b as 45 over 7 minus 8 over 7 and minus 9 over 7, right? So to get the equation of this line AB, we can make use of the symmetric form of the equation of the line, that is x minus x1 over a, y minus y1 over b, and z minus z1 over c, where a, b, c are the direction ratios of this line AB, and x1, y1, z1 can be taken as this point 1 comma 2 comma minus 1, or this point, that is 45 over 7 comma minus 8 over 7 comma minus 9 over 7, right? So here we'll take x1, y1, z1 as this point. So we have x minus 1, then we have y minus 2, and then we have z minus 1, and a, b, c are the direction ratios of AB, and which can be obtained by subtracting the coordinates. So a is given by 45 over 7 minus 1, then b is minus 8 over 7 minus 2, and then here we have minus 9 over 7 minus 1 as c. So we have x minus 1 over 45 minus 7 over 7, then y minus 2 over minus 8 minus 14 over 7, and then z plus 1 over minus 9, and here it is positive, so we have plus 7 over 7. So now we can write x minus 1 over 38 over 7, and then we have y minus 2 over minus 22 over 7, and then z plus 1 over minus 2 over 7, right? So the direction ratios of the line AB are 38 over 7, minus 22 over 7, and minus 2 over 7. And now we can write these three numbers in lowest form. That is, we know that if two vectors or two lines are parallel, then their direction ratios are either equal or proportional, right? So now 38 over 7 comma minus 22 over 7 minus 2 over 7 can also be written as 38 comma minus 22 minus 2, because here we have 1 over 7 as the common factor, and again if we divide throughout by 2, then we have 19, then here we have minus 11, and here we have minus 1, right? And if we again divide these three numbers by minus 1, we can write minus 19, then here we have 11, and here we have 1. So the direction ratios of this line AB can be taken as minus 19 comma 11 comma 1. So the equation of this line AB is now x minus 1 over minus 19, then we have y minus 2 over 11, and then z plus 1 over 1. So this is the required equation of the line joining the given point and its image, that is point B.